In this video, we are going to be learning about operations with functions. So if we look at number 1, we are given this function notation h of 5. So I want you to be very clear on how you read this. This is read as h of 5. And so when we have h of 5, what that is telling us, the h out in front is telling us to look at the function h of x. So if you look up at the top of our notes here, you'll see that we have f of x, g of x, h of x, and j of x. This h out in front is telling us to look at the function h of x equals 3x minus 2. The 5 inside parentheses. We'll notice that in this one, x is inside parentheses, and now we have the 5 inside the parentheses. That is telling us that x equals 5. So every time we see an x in h of x, we are going to replace those x's with a 5. So h of x is now going to be h of 5. And instead of 3 times x minus 2, I'll have 3 times 5 minus 2. This side over here is just notation. There's nothing to solve on the left side. This is saying we're evaluating the function h when x equals 5. This is a side that we can evaluate. When you're doing this, you're just using the order of operations. Multiplication before subtraction. So 3 times 5 is 15. 15 minus 2 is 13. So h of 5 is 13. There's a couple different ways that you could write your answers. You could just write 13. You could say h of 5 is 13. Or you could write it as an ordered pair. When you input 5, 13 is your output. So 3 different ways that you could write that answer. Let's try this again with example 2. Here we have f of 1. So f out in front is telling us to look at the function f of x. And then the 1 inside is telling us that x equals 1. So every time I see an x in f of x, I am going to replace that with a 1. So I'll have 16 times 1 squared minus 1. Again, I'm just replacing the x in f of x with a 1. So I'm going to use the order of operations. Exponents first. So 1 squared is 1. 16 times 1 is 16. 16 minus 1 is 15. So f of 1 is 15. On example 3, we are asked to find j of 2x. The j out in front tells us to look at the function j of x. The 2x inside is telling you, okay, every time you see an x in j of x, replace it with a 2x. So let me show you what that looks like. So j of x is x cubed plus x squared. And every time we see an x, we're going to replace it with 2x. So now we have 2x cubed plus 2x squared. Well, 2x cubed means that I have 2 cubed times x cubed. So that's 8x cubed. Plus 2x squared is 2 squared is 4, and x squared is x squared. These are not like terms. This is as far as I can take this one. So here, j of 2x equals 8x cubed plus 4x squared. On example 4, we have g of x minus 1. So the g out in front is telling us to look at the function g of x. And every time we see an x in g of x, instead of writing an x, we're going to replace it with x minus 1. So instead of 2x that we had for g of x, we now have 2 times x minus 1. So to simplify this, we'll use a distributive property, and we'll find that g of x minus 1 is 2x minus 2. And that would be our answer. On number 5, we're adding two functions together. We have f of x plus j of x. So let's look up here. F of x is 16x squared minus 1. So I'll have 16x squared minus 1 plus j of x is x cubed plus x squared. So when I go ahead and add these together, I'm just looking for like terms, and I'm going to write my answer in standard form. So it looks like x cubed doesn't have a like term, so I'm going to bring that one down. 16x squared plus x squared is 17x squared. And then negative 1 doesn't have a like term, so I'll bring that one down. So f of x plus j of x is just x cubed plus 17x squared minus 1. On example 6, we have h of x minus g of x. So let's look up here. H of x is 3x minus 2 minus g of x, g of x up here is 2x. Now notice how I put everything in parentheses. That's because, remember, when you are subtracting, you have to remember to distribute that negative sign. So here it's really like I have 3x minus 2 minus 2x. If I combine like terms, 3x minus 2x is 1x. And negative 2 doesn't have a like term, so I'll bring that one down. So my answer is x minus 2. On example 7, it wants us to find g of 4 minus f of 4. So first I need to evaluate g of 4. So remember, g of x up here is 2x. So if I find g of 4, g of 4 is going to be 2 times 4, which is 8. And then f of x, again, if I scroll up here, f of x is 16x squared minus 1. So f of 4 is going to be 16 times 4 squared minus 1. So if I grab my calculator, let's see. So my calculator, I'm just doing 16 times 4 squared minus 1, and I get 255. And so we want to do g of 4 minus f of 4. So that's going to be 8 minus 255. So 8 minus 255 is negative 247. And that is my answer. On example 8, we want to find j of 2 plus h of 2. Well, j of 2 is going to be 2 cubed plus 2 squared. 2 cubed is 8. 2 squared is 4. 8 plus 4 is 12. H of 2, let's see. H of 2 is going to be 3 times 2 minus 2. So that's 6 minus 2, which is 4. So I'm going to have j of 2 is 12 plus h of 2 is 4. 12 plus 4 is 16. So that would be my answer. On the next page, we have the same functions, and now they want to do f of x times j of x. Well, f of x, I can see up here, is equal to 16x squared minus 1. Again, put your parentheses around your function. And we're multiplying that by j of x. J of x is x cubed plus x squared. Well, I have a binomial being multiplied by a binomial. To multiply two binomials together, we learn to use the area model. So I'll have 16x squared minus 1 going down the side, and x cubed plus x squared across the top. 16x squared times x cubed is 16x to the 5th. 16x squared times x squared is 16x to the 4th. Negative 1 times x cubed is negative x cubed. And negative 1 times x squared is negative x squared. I don't have any like terms, so I just need to write my answer in standard form. And so my answer is 16x to the 5th plus 16x to the 4th minus x cubed minus x squared. On example 10, we have h of x being divided by g of x. Whatever comes first is your numerator, and whatever comes second is your denominator. So h of x is 3x minus 2, that's my numerator. My denominator is g of x, which is 2x. So you could separate this out into two fractions. So you would have 3x divided by 2x minus 2 divided by 2x. So this first one would reduce to 3 over 2. And on the second one, our 2's would cancel, leaving 1 over x. So your answer is 3/2 minus 1 over x. On example 11, we want to find g of negative 2 divided by j of negative 2. Again, this will be your numerator, and this will be your denominator. So let's find g of negative 2 first. G of negative 2 is going to be 2 times negative 2, which is negative 4. So negative 4 is in our numerator. J of negative 2 is going to be negative 2 cubed plus negative 2 squared. Again, it's really important that you're using parentheses, right? Because we want to cube the negative sign. So negative 2 cubed is negative 8, and negative 2 squared is positive 4. If you don't have parentheses around that negative 2, when you square it, it would give you a negative 4. So that's why it's really important that you use those parentheses. Negative 8 plus 4 is negative 4. So for my fraction, I have negative 4 divided by negative 4, which is positive 1. That is my answer. On example 12, we have f of negative 1 times h of negative 1. So if I look at the function f of x, I'm going to replace negative 1 every time I see an x. And so that's going to give me negative 1 squared is positive 1. 16 times 1 is 16. 16 minus 1 is 15. So I'm going to have 15 times, and then h of negative 1, every time I see a x in h of x, I'm going to replace that with negative 1. And so I'll have negative 3 minus 2, which is negative 5. So in my calculator, I'm going to do 15 times negative 5. And I'm going to get negative 75 as my answer. These next ones are called composition functions. And so you would read this as h of g of 5. So basically every time you see a parentheses, the parentheses is the word of. So h of g of 5. To find this, you start with the inside. G of 5. So we can find that. G of 5. That means every time you see an x in g of x, you're going to replace it with a 5. So instead of 2 times x, I'll have 2 times 5, which is 10. So that means that g of 5 inside this first, or inside the first parentheses, is 10. So now, instead of h of g of 5, g of 5 is 10. So now I'm finding h of 10. Well, h of x is 3x minus 2. So every time I see an x in h of x, I am going to replace it with a 10. So I'm going to have 3 times 10 minus 2. 3 times 10 is 30. 30 minus 2 is 28. So h of g of 5 is 28. Let's try that again with this next one. Here I have g of h of 0. So I'm going to begin by looking at the inside, which is h of 0. So every time I see an x in h of x, I'm going to replace it with 0. Remember, I'm getting h of x from up here. So I'm replacing this x with a 0. So I'm going to have 3 times 0 minus 2. Well, 3 times 0 is 0. 0 minus 2 is negative 2. So h of 0 is negative 2. So now I'm going to find g of negative 2. Basically, all you're doing is you're taking the answer from the first one and plugging it in for x in the second one. So g of negative 2, that tells me that every time I see an x in g of x, I'm going to replace that with a negative 2. 2 times negative 2 is negative 4. This is my answer. Let's try that again with example 15. On example 15, I have f of g of x. So, g of x. If we look at the top of the page, g of x is 2x. So that means that every time I see an x in f of x, I'm going to replace it with a 2x. And again, f of x is 16x squared minus 1. So now we're going to find f of 2x, because we're just taking that and plugging it in. And now we're going to simplify. So I'm going to bring down my 16. 2x squared is 4x squared. 16 times 4x squared is 64x squared minus 1. This is your answer. On example 16, we have g of f of x. F of x is 16x squared minus 1. We're going to plug this answer in here. So now we're going to find g of f of x, but we know that f of x is 16x squared minus 1. So that means that every time we see an x in g of x, we are replacing it with 16x squared minus 1. So from here, all I have to do is distribute. 2 times 16x squared is 32x squared. And 2 times negative 1 is negative 2. This is my answer.